All right, we're back on this 2004. This is, I think, is the third video. So right there you can see we're tracking or data logging the actual on and off call from the thermostat, the temperature sensor that tells the compressor to shut off and on, because we don't have a high load on the vehicle under these ambient conditions. And we're at 70 degrees, 77 degrees right here. Actually, that is the roll around temperature of hot air being sucked up in front of the car, because you just come out here a few days. If you could see outside, I don't know if you can see it, it's actually raining right now. Let's see if I could zoom in. I don't know if you could catch the rain or not, but it's only 56 degrees outside. There's no heaters in this shop. This is just the roll around air. You can see how the air is blowing here and under the car, and the air actually rolls around and keeps this local area hotter. And it's only reading from right here. That's the temperature sensor. And just by moving it, it depends where I move it. So if I move it right outside of the grill, so when it was on the inside of the grill, it's 77 degrees. I'm gonna get it right here on the outside of the grill. Now we're just on the outside of the grill at this point right here. Look at where the temperature goes. 60 degrees. But it's only 54 degrees. So that's at that location. Now if I move it up here, it'll be a different temperature. And if I move it down here where I can feel the heat coming back and around, rolling around, it'll be a different temperature right here. Everywhere is a different temperature. There's no one temperature point. And different vehicles blow and circulate air around differently, and it becomes more apparent the hotter the vehicle is and the colder it is outside. You can measure the temperatures more drastically and you can see it. So this is the cycle time. You see we're going into 11 minutes right here. If I can get it to focus, we're going into 11 minutes right now. That's your low side pressure goes down to 24.2 degrees. It kicks back in, looks like it's closer, almost 39, almost 40 degree, 40 PSI. At 40 PSI it kicks in, at 24 PSI it kicks out. Now if you go up to the high side, our lows are down to somewhere around 96 PSI. If we can get it to actually focus. It doesn't like focusing on bright things. So if we get up here, we're approaching 120, because you can see the 120 mark right there. We come up to right around 120 and we get down below the 100, around 96 PSI. So it's a constant cycle. This is how this vehicle operates under these ambient conditions, with no heat load of the sun, so there's no radiant load. The ambient temperature is lower. If we come up and you take a look at the temperature, now this is the front and rear expansion valve from the front and rear evaporator. There's two evaporators in this vehicle. You have a front evaporator and a rear center console evaporator. And as you can see, we are cold. It's condensating. So there's an evaporator inside here, separate second evaporator. And you can see where my sensor is. I'm taking the temperature right out of this duct, and I'm taking the temperature right out of that duct there. So they're tracking as the clutch cycles on and off. And you see they're only a few degrees apart. You'll usually always see the rear evaporator a few degrees warmer. See that says 46 degrees, 43 degrees, 46 degrees. Whoa, what happened? Oh, I hit the humidity, 88% humidity in there. Let's go back to this. So you see it's constantly 43 degrees, 46 degrees. So it's tracking together, and they're a few degrees apart. And as you measure all your front and rear combinations, you will usually come across the rear evaporator is a little bit warmer than the front evaporator. All right, that's it for now. I got to get off to the next one, and I'll see you guys tomorrow.